In this video, we will discuss about the representation of the system of linear equation in the matrix form, and we will discuss some elementary row operations on the matrix which will be helpful to obtain the triangular form of a matrix. And we also discuss echelon form of a matrix and reduced row echelon form of a matrix. There is no issue when we have a system of linear equation in two variables or three variables, but the problem occurs when we have the number of equations and unknowns in a linear system increases. So the complexity of the algebra involved in finding the solution, it will also increase. So the required computations can be made more manageable by simplifying the notation and or by following some standard procedure. So we will use matrix notation to represent a system of linear equation. For example, suppose we have a system of m linear equations in n variables. Then this system of linear equation can be written in the matrix form as
this equation. So if you see here, we have three matrices. The first one is the matrix of the coefficients of the variables, and we have another matrix of the variables, and the third one is the matrix of the scalars. So in the first matrix, the first column is the coefficient of the variables x1. Second column is the coefficients of the variable x2, and the nth column is the coefficient of the variable xn. This matrix is the matrix of variables of x1, x2, xn, and this is the entries of the right hand side in the system of linear equations. These are all scalars. So this we denoted by as A. We denote the matrix of variable by x, and it is denoted by B. So we called matrix A as the coefficient matrix. This is called as variable matrix. This is a column matrix, and this is the matrix of scalars, which are the entries of the right hand side in the equation.
now let us see with the help of an example of a system of linear equations in three variables how we write it down it in the form of the matrix notation. So we have this system of a linear equation. So its a coefficient matrix A will be what? A will be a 3 by 3 matrix whose first column will be the entries of the coefficient of x, that means 1, 2 and 3. Second column will be -2, -3, -1, and third column will be 3, 4 and 4. So as I told you that the first column will be the coefficients of x, second column in the coefficient matrix will be the coefficient of y, and third column will be the coefficient of z. X is your the variables x, y and z variable matrix, and B is the matrix of the scalars of right hand side entries of the system of linear equations. So this is your B. So it means this system of linear equation can be written as AX is equal to B. Now, one more form of the matrix which will be useful in solving a system of linear equation is the augmented form of a matrix. So augmented matrix of the system of linear equation is written as A is to B, or sometimes you are just extending a coefficient matrix with the B. So this is totally optional. So just you write down the coefficients matrix, and then this is matrix B. So this matrix together with these two is called as augmented matrix. Now, one more notation or the terminology which we will use when we will solve the system of linear equations, the triangular form of a system of linear equation. So, a system of linear equation in this form. So that's why you can say that this is in the form of a triangle. So it is called as the triangular form of a system of linear equation. So we will see it also when we will solve a system of linear equations by various methods, which we will discuss in our subsequent lectures. Now, let us move to the next some elementary operations on the matrices, which will be helpful to solve the system of linear equations. Elementary row operations on a matrix. So we have three row operations which we will use on the augmented matrix to obtain the solution of the system of linear equations. The first operation is multiply a row by a non-zero constant. Second operation, interchanging of two rows. Third operation, add a constant times one row to another. So these are the row operations. For example, suppose we have this matrix A. So let us see what is first row operation is saying: multiply a row by a non-zero constant. So in place of row 1, you can do, suppose, 2r1. That means you are doing operation in row 1 by multiplying by a non-zero constant 2. So you will get the new matrix. Suppose it is a dash. So a dash will be in the first row multiplied by 2. So this is the matrix which is obtained after introducing the row operation first. Let me give you the example for the second one. For second operation, interchanging of two rows, suppose you interchange row 2 and row 3. So you will get matrix A. We just change the name as double dash. This is just only a notation. Add a constant time one row to another means, suppose in row 3, this is our example of third one, a triple dash. This is just only a notation again. Let me probably. So first two rows will remain same. In row 3, we are going to add R1 plus 2 R2. So R1 is 4, 6, 2. R2 is, add them, 12. So we have 12, 8, 8. So this is our elementary row operations which we will use in solving a system of linear equations. Now, let's come to the Echelon form. So, what is Echelon form of a matrix? So, first of all, I would like to tell you that what is Echelon. Basically, this is a military term that is used to describe a particular formation. For example, if you see this picture, you can see that the planes are in Echelon form because they are in a particular formation in which each plane is forwarded to the right to its previous plane. Now, before getting into the definition of Echelon form of a matrix, let me introduce you some terminology. So leading entry. So to find whether a matrix is in echelon form, we must look at the leading entry in each row. So what is leading entry? So leading entry in a matrix is the first non-zero entry in that row. For example, consider the matrix. In this matrix, if you see that first non-zero entry in the first row is 5, so this is leading entry, this is leading entry. In the third row we do not have any non-zero entry, so there is no leading entry, and in the last row this is first non-zero entry. So these are the leading entries of a matrix. Now let me discuss the definition of echelon form of a matrix. So echelon form of a matrix is in echelon form if it satisfies the following three conditions. Any rows of all zeros are below any other rows. That means a matrix will be in echelon form if it has any zero row, it must be in the bottom. Second point is each leading entry of a row is in a column to the right of the leading entry in the row above it. For example, suppose you have a matrix. So if suppose you have leading entry here in this row, so the next in the next row leading entry must be in the right column, either here in this column or here in this column. It cannot be in the same column. And all the entries in a column below a leading entry are zero. So if suppose this is a leading entry, this is leading entry, and this is leading entry, so all the entries below this leading entry must be all zeros. If these three conditions are satisfied, then we say that the matrix is in echelon form. So let us see with the help of an example. Suppose we have this matrix A. So first we will identify the leading entries. This is first non-zero entry. This is first non-zero entry. And this is first non-zero entry. So first condition, any rows of zeros of all zeros are below any other row. So this matrix has a zero row which is in the bottom. So first condition checked. Second condition, each leading entry of a row is in a column to the right of the leading entry in the row above it. It means leading entry to the right, leading entry to the right. That means second condition, check. Third point, all entries in a column below a leading entry all are zeros. So leading entry, all entries are zeros, all entries are zero, all entries are zero. So we can say that this matrix A, it is in echelon form. Let us see another example. First identify the leading entries of a matrix. So this is first non-zero entry, first non-zero entry, first non-zero entry. Now check the conditions. If it has a zero row, it must be in bottom. So you can see here this is a zero row, but it is not in bottom. So we can see that this is not in echelon form. Let us check the other conditions also. Each leading entry of a row is in a column to the right. So you have leading entry as 5, 2 and 1. Next leading entry after 1 is in the left side, but we must have leading entry to the right column. So that means second condition is also not satisfied. Even for the third one also not all elements below the leading entry are zeros. So these three conditions are not satisfied. Even if one is not satisfied, then it is not an echelon form. But just I want to check it. Now, let us discuss about a reduced row echelon form. A matrix is said to be in a reduced row echelon form if it is an echelon form. Second condition is all leading entries are 1. Third condition is except leading entries, all entries in the column are 0. So if these conditions are satisfied, then we say that that matrix it is in reduced row echelon form. First condition, it should be in echelon form. Echelon form means if any matrix have 0 rows, it must be in bottom. Each leading entry of a row is in a column to the right of the leading entry in the row above it. And the third one, all the entries in the column below a leading entry are zeros. All leading variables must be 1, except the leading entries. All entries in the corresponding column must be 0. If these conditions are satisfied, then we say that the matrix is in reduced row echelon form. Let me give you an example. You see here leading entries are 1. So it has 0 row which is in the bottom. Each leading entry is towards to the right to the next leading entry. Second condition is satisfied. All the entries below the leading entry are zeros. So this matrix is in echelon form. Now, to be it is in a reduced row echelon form, all the leading entries must be 1. So leading entries are 1, and in that corresponding column, leading entry is the only non-zero entry. So you see that all the in the column all the entries are zeros, so that means we can say that this matrix it is in reduced row echelon form. Now the last concept which is very useful in linear algebra, and we will use it in our subsequent lectures. It is worthy to mention here. It is about a rank of a matrix. So rank of a matrix is what? Rank of a matrix is nothing but the number of non-zero rows of the matrix in echelon form. That means if you have to find the rank of a matrix, reduce it in echelon form and just count the number of non-zero rows. That will gives you the rank of a matrix. For example, if you see here, we already seen that this matrix is in echelon form. So how many rows are there? Non-zero rows 1, 2 and 3. So we can say that this matrix has a rank 3. So rank of a matrix, you can say that just the number of leading entries of the matrix in echelon form. Just one more thing, leading entry is also called as pivot element. Some book use this word, some books use leading entries. Okay, so I hope that this lecture is helpful to you. So if you like it, please share and subscribe to my channel. Thank you.